Okay, so for this problem, we're doing an evaluation. Let's see, we've got a function of three variables. We've got a solid three-dimensional thing. So evaluation in this context of solid three-dimensional domains and scalar valued functions of three variables, evaluation means triple integral. So we're computing a triple integral here. But if you look at this integrand function, it's brutally ugly. And you have to ask yourself, am I that mean? To make you do something that rough, and think, strategically think to yourself, maybe not, right? And in fact, I'm not. I mean, this is actually not a bad problem. This is a symmetry problem. So let me write some of this down. We've got a triple integral. Now this is over the solid unit ball. And we've got this nasty function, x squared y to the fourth times arctan of 1 plus y minus arctan of 1 minus y. Okay, dv. Yikes. Wouldn't it be nice if that function had odd symmetry in some way or another? Furthermore, if it had odd symmetry with respect to some symmetry shared by the ball. Now, good news, balls have all sorts of symmetry. Right? In fact, reflect over pretty much any plane going through the origin, it's fine. So we just have to ask ourselves, what might we do to this function to make it go negative? Well, what if I replace x with negative x? No, tragically, doesn't work. What if I replace z with negative z? Doesn't do anything. There aren't any z's in here. If I replace y with negative y, though, that term, that factor, doesn't change. But I claim when you replace y with negative y, this becomes exactly the negative. These terms flip over. The plus becomes a minus. The minus becomes a plus. And I claim that, let's call this function f. I claim that f of x negative yz is indeed exactly the negative of f of x, y, z. So this function f that has odd symmetry with respect to, well, whatever the symmetry is that changes the value of y. This is what we have is that f is odd symmetry through what we call the xz plane, because that's the plane that does that make sense? Yeah. Okay. So then you have to add. So by the way, this needs to be shown. Right. This calculation here, that this minus sign is there. Okay. Right, and then of course B is symmetric through the same plane, and so therefore the triple integral in question is 0. Yeah. Always be on the lookout for these symmetry things. Okay. Any further questions about this one? Everybody good?